Hello and welcome everyone. In this video we will see how to do the basic commissioning of the TPD500 using WebDrive Labs. WebDrive Labs is a PC-based configuration tool and it allows easy and intuitive access to all parameters and functions of the drive. The connection between the PC and the drive can be established in two ways: wired using a standard Ethernet cable or wireless via the Wi-Fi drive link module, which is optional and not included in the standard supply. For this video tutorial, we start from the condition where the drive is already connected to the mains and to the motor, and the WebDrive Labs is already installed on the PC. In this case, the PC will connect to the drive wirelessly using the Wi-Fi drive link module that has to be connected here. To start the commissioning, make sure that both the armature and the control board are powered. There is no need to power the field at this stage. In this setup, we are also using a control box, which is used to send the enable command to the drive. This command is always required. Finally, before starting, also ensure you have the nameplate data of both the motor and the speed sensor used for feedback. In this example, the speed sensor is a digital incremental encoder. Let's get started. First of all, open WebDrive Labs, in this case by double-clicking the icon on your desktop. On the home page, you'll see both industrial and lift drive option. This is because the same tool is used to configure drives from both the TPD500 and ADL500 families. As mentioned earlier, in this example, we connect to the drive using the Wi-Fi drive link module. First, make sure your PC is connected to the Wi-Fi network of the module. Okay, we are now connected. Then click the Start Scan button on the home page. As you can see, the TPD500 drive appears right away. Click the Add button to connect and open a new project. As you can see, from the status, we are now successfully connected to the drive. Now click the wizard button to open the Startup Wizard windows. Just like the keypad commissioning, this is a step-by-step procedure for the basic setup of the drive, but in this case, it's even easier and more intuitive. You can move through the different steps using the Next and Previous or Arrows button here. In this first step, you are asked to enter the main parameters of the drive. The armature current is read-only as it depends on the drive size, in this case 20 amps. As for the field current, the default value is the maximum supported by the drive, in this case 6.25 amps. However, we recommend setting this parameter and adjusting the S14 dip switch on the control board accordingly to optimize the current scaling based on the motor being used. In our example, the motor's nominal field current is 1.4 amps, so we'll set the parameter to 2 amps and configure the S14 dip switch accordingly, referring to the tables providing the manual. Finally, we can leave this parameter set to off, since in this example we are not using an external 4-quadrant field controller, which would allow motor reversal when paired with a 2-quadrant armature converter. By pressing Next button, we move to the next step. In the second step, you are asked to set 2 additional key parameters for drive management. This first one is the full-scale speed in RPM. This value affects all speed-related parameters of the drive. Since the motor has a nominal speed of 2370 RPM, we set this parameter accordingly. The second parameter, main commands, defines how the drive is controlled. In terminals mode, control signal come exclusively from the control box, while in digital mode, the control is managed via a digital communication channel, such as Modbus TCP through WebDrive Labs. but terminal signals through the control box are still required. For this example, we select digital mode. By pressing the next button, we move to the next step. In the third step, you are required to enter the motor nameplate data. In this example, set both the motor rate speed and the motor maximum speed to 2370 RPM. Depending on the motor and the application, the maximum speed may be higher than the base speed. In such cases, field weakening is necessary. Next, set 15.8 amps as the rated armature current. 400 volt as the rated armature voltage, and finally 1.4 amps as the rated field current. By pressing next button, we move to the next step. Continuing with the steps, now we need to select the feedback signal to be used for motor speed control. As mentioned at the beginning of the video, in this example we are using a digital incremental encoder, specifically encoder 2, which is the default option. Therefore, we can skip the next step and go directly to the encoder 2 configuration. As with the motor, we also need to rely on the encoder's nameplate data. The encoder is an HTL type with 1000 pulses per revolution. For this reason, it is sufficient to enter the incorrect number of pulses and leave the other parameters at their default value, as they refer to TTL encoders. Finally, make sure that the switch labeled plus 24VE2 on the control board, which provides power to encoder 2, is set to on. By pressing the next button, we move to the next step. Since we are not using tacho generator as a speed feedback, we can skip this step and move to the next one. In this section, you are required to set the limits for speed, torque current and field current according to the specific application. In this example, we keep the default value of 0 RPM for the minimum speed in both direction of rotation and 4740 RPM as the maximum speed for both directions as well. This value corresponds to twice the full-scale speed set earlier. Regarding the torque current, we leave the default value of 100%. This percentage refers to the rated armature current we set earlier. Finally, for the field current, we keep both default value, which are also expressed as a percentage of the rated field current. The minimum value, 30% in this case, correspond to the field current when the field weakening is enabled at 0 speed. By pressing the next button, we move to the next step. In this section, you are required to set the basic parameters for configuring the speed reference. For this example, we set analog input 1 assigned to off, and use the following parameter to set the desired speed reference. For now, we enter 100 RPM. Later, during the final verification test, we will set different speed reference by adjusting this parameter. Now, by pressing next button, we move to the next step. Continuing with the commissioning process, this step is one of the most important. We are now going to perform the current regulator auto-tuning. This is an automatic procedure that calculates two key motor parameters, resistance and inductance. These values are essential for the operation of the predictive current control, which is enabled by default and provides better performance than a traditional PI controller. To start the auto-tuning, click the Auto-Tune Start button, and close the enable input on the control box. Please note, depending on the motor, the procedure may take a few minutes. You can stop it at any time by pressing the Auto-Tune Brake button or by disabling the drive. When the procedure is completed, remember to open the enable input again. Now, by pressing the next button, we can move to the next step. We are now at the end of the commissioning process. In this section, you can configure the field control parameters. By default, field control is enabled and we keep it in that way. As for the mode, we select current control, since we don't need to apply field weakening to operate above the nominal speed. Using this parameter, it's also possible to manage cases where the motor field is controlled by an external device, separate from the armature control. For example, a drive from the TPD500 FC series. As mentioned, we keep field weakening disabled, while keeping field weakening at 0 speed enabled, which corresponds to 30% of the nominal field current, as set in a previous step. By pressing the next button, finally, we save the parameters to ensure that the defined configuration is retained even after the drive is powered off. The standard commissioning procedure is now complete. By powering the field as well, we can perform a quick test to verify that the motor runs correctly by providing a speed reference using the ramp-ref1 dig parameter we mentioned before. Since we previously set main commands to digital, we still need to provide both the enable and start commands via the control box, as well as send the corresponding digital commands through WebDrive Labs. To do this, we can either use the individual specific parameters or the virtual keypad, which is more intuitive and easier to use. The virtual keypad is enabled by clicking this icon. As you can see, by pressing the enable button, the drives enter the ready state. And by pressing start button, it begins operations, reaching 100 RPM we set earlier. The virtual keypad already displays the main parameters. Additionally, we activate the graph window, which allows us to monitor selected signal over time. The graph windows is enabled by pressing this icon. For example, we can monitor the motor speed, which is in this case the speed measured by the encoder, and the speed reference. That is the reference that we want the motor to follow. Now we set different speed references by changing the ref1 dig value in the reference menu. For example, 500 RPM, then 1000 RPM, Finally, to stop the motor, we can also act digitally by pressing the stop button on the virtual keypad. Here. As you can see here, at 0 speed, the field weakening is enabled by providing 30% of the nominal resistant current. That's it for this video. For more drive parameter settings and advanced features, check out the TPD500 user manual in the link below. And don't miss the other videos in this series. If you have any questions, feel free to reach out to our field service team. We are here to help. Thank you.